Okay, this is my networks assignment. So we'll be starting the peer now. As you can see, all the peers are being pinged correctly. So one of my design choices was to make the peer successors into a module instead. So as we can see here, we have a method to handle pinging to our successor. This uses a send UDP method and this is to just reduce redundancy. As you can see, it uses a UDP socket, which we have defined over here. And as you can see, send ping uses is basically what sends all the pings out. And we have a suck.ping. And so this is calling the method which pings one of our successors. We have a receive ping, which is basically a listener on our UDP socket. And when we send something, we send it through the same socket using a UDP packet back out. We know this is a UDP socket because we pass in a UDP socket parameter into the initialization of this function. So now I'll show requesting a file. So we'll be requesting from peer 8, and we request the file 2012. And as you can see, it shows up in all the proper ones. And here, so this is where we actually request the file from our first successor, and we use our request file method in order to do it. As you can notice, it has a send TCP wrapper, and this TCP wrapper just creates a new connection, sends the data, and then closes the socket for us. If we look inside our send TCP handler, like a bit further down, here we are, we notice that we have our file command, and this is where we actually figure out whether or not we want to, whether the file is here or whether it's not. So we have the send TCP for when we find a file, and we have our request file, and we just forward it onto our next successor. So send TCP does a similar thing where it just creates a new socket, sends the data across it, and then closes the socket for us. Next, we want to make peer 10 quit. As you can see, peers 8 and 5 have both picked up this change. And if we look into, like here's the pings, and we can see they're pinging correctly. So if we request a file, we're requesting 10, we notice that goes to peer 12 instead now. So the network has properly updated itself. So as you can see here, we send TCP in order to show that we wanted to quit, and our payload was a goodbye. So if we look into our, so here's the send TCP stuff. And if we look into our TCP socket listener, we notice that it's we have a goodbye command, and basically confirms that it says goodbye, and it sends this using send TCP itself, and then it also has to receive the done for it, and that's also done through the same through TCP as well. Finally, we want to cause an unexpected quit, so we have quit node 5 of the network, and now we wait about 30 seconds until it will, nodes 3 and 4 will notice that the peer has left the network. And as we can see, peer 4 has now picked up the change. Peer 3 takes a little bit longer because I wanted to prevent a race conditioning happening. So, and now if we request a file from 15, request the file 5, we'll notice that it will go to its next successor instead.